With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is a tuning fork of unknown frequency makes 5 beats per second with another tuning fork which can cause a closed organ pipe of length 40 centimeter to vibrate in its fundamental mode. Alright, so the second tuning fork can cause the closed organ pipe to vibrate in its fundamental mode. The beat frequency decreases, so it is given that beat frequency decreases when the first tuning fork is slightly loaded, okay, with wax. Find its original frequency. So we need to find the original frequency of the first tuning fork. The speed of the sound in air is given as 320 meters per second. So in the question we are given the number of beats per second denoted by n equals 5. We're also given length of the pipe, let's call that as LP, equals 40 centimeter, and we need to find the fundamental frequency or the original frequency of the first tuning fork, so let's call that nu 1. So before we solve this question, let us first discuss some key concepts that we need to know to solve this question. So there would be a number of key concepts. So the first key concept is the frequency for closed organ pipe. So let's call that as nu p, which is given by V upon 4LP, where V is the velocity of sound in air and LP is the length of the pipe. The second key concept is the concept of resonance. So in the question it is given that the second tuning fork can cause the closed organ pipe of length 40 centimeter to vibrate in its fundamental mode, which means the second tuning fork and the closed organ pipe are in resonance. So we can say nu 2, that is the frequency of the second tuning fork, equals frequency of the closed organ pipe. The third key concept is the concept of beats, which is given by nu 1 minus nu 2 mod equals to n. Nu 1 and nu 2 are frequencies of two tuning forks and n is the number of beats per second. The fourth and the last key concept would be loading of fork. So when fork is loaded, what happens? Its fundamental frequency will decrease. So as the first tuning fork is loaded, so the first fundamental frequency will decrease. So now we can proceed to solve this question. As we need to find nu 1, so we can find nu 1 from this equation. To find nu 1, we need nu 2 because we already have n. To find nu 2, we need nu p from the second key concept, and nu p can be found out from V upon 4LP equation. So we will first start with this equation. So let's first find nu p. So nu p is V, that is 320 meters per second, divided by 4LP. LP is given as 40 centimeters. So we will convert this into meters. Now on solving, we will get nu p as 200 Hertz. Now from our second key concept, we know nu 2 equals to nu p. So from here we will get nu 2 equals to nu p, which is 200 Hertz. Now we can proceed with the third equation to find nu 1. So third equation is a mod equation. So on opening mod, we will get two equations. So we have either nu 1 minus nu 2 equals to n, or nu 2 minus nu 1 equals to n. Only one of the equations is applicable in our case, so we need to find which one is applicable. So in the question it was given that the beat frequency decreases when the first tuning fork is slightly loaded. So the beat frequency is decreased, so we can say n decreases. Also from our key concept we know when the fork is loaded, its frequency would decrease. So as first tuning fork is loaded, so nu 1 would decrease. So these two conditions are simultaneously possible only in one of the equations, and that is this equation, because in the second equation, if nu 1 decreases, n would increase. Alright, so this is wrong. So we will be using this equation to find nu 1. So from the first equation we have nu 1 equals n plus nu2. The number of beats in the question is given as 5. So we will put n equals 5. Nu2 we have already obtained as 200. So this would be 200. So from here we will get the original frequency of the first tuning fork as 205 Hertz. So this is our answer. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.